Hi everyone, myself Dr. M. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about introduction to graphs. So, what is a graph? So, graph is nothing but a collection of points in the plane called vertices or nodes, and some of them connected by line segment called edges or arcs. So graph is nothing but a collection of points in the plane called vertices or nodes. Okay. And some of them which is going to be connected by means of a line segment. So that should be called as edges and arcs here. And the convention for representing that is that so G of V comma A. So V should be the set of vertices and E should be set of edges here. So in this graph, so this should be the node. So this node can be called as a vertex or device, and this line segment what we called as an edge or it may be called as an arc. So what are different categories of graphs? So the graph is that so the two types of graphs are available. So directed graph and undirected graph. So the other synonym what we called as directed graph is digraph. So that means a pair of ordered vertices. And undirected graph so is nothing but the pair of unordered vertices. So here uh, the edge it is going to represent an arrow, so that is the edge what we call the graph as directed graph or digraph. So in this case the edge is from A to B, so we may not go from B to A since there is no directed edge here. Similarly, we have an edge from B to C. We may not go from C to B easily. And A to C, there is no edge here. So that is the way of presenting the edges in directed graph. So that's why UV may not be equal to VU. So when it comes to undirected graph, so it should be the pair of unordered vertices, UV and VU. That should be the same since uh, there is no directed edge in between them, then I can able to call it as undirected graph. So here I have an edge from A to D, so that means I have edge from A to D as well as D to A. So this should be the edge E1, and similarly I have an edge from A to D, D to C to D, so and as well as E3, E4, C to D and D to C as well. So like this, we are going to get this edges in undirected graph. The edge may not have directions in undirected graph, and edge may have directions in this diagram or directed graph. So what are the various representations of a graph? So normally we are going to follow two types of conventions. So first one is that adjacency matrix, and second one is that adjacency list. So what is this adjacency matrix here? So if I'm going to have a graph like this, A, B, C, D, and in this case of adjacency matrix, so this is the matrix which is going to be represented in the form of zeros and ones. So what are the vertices are there? That one I'm going to take here. So A, B, C, D, and similarly I'm considering also. So whenever there is an edge from A to B, I'm going to mark as 1, and I don't have another kind of edges also. So here what I'm going to say next one. So remaining all are zero. So there is no edge from A to A as well. So that's why it should be zero. And from I have edge from B to C. So that's why it should be one, and otherwise it should be zero. And I have edge from C to D and B to C also. C to D and C to D. B to C. So it should be zero. And I have edge from D to C. So it should be zero. So this matrix what we called as an adjacency matrix here. So whenever there is an edge, it should be marked as 0 or 1. It should be. Then, so same thing if I'm going to represent, so A to B, A to C and this one. So how the matrix will be in case of this directed graph. So for this, so if I'm going to have an edge from, there is no edge from any other vertex, so there should be 0. But I have an edge from B to A and I have no other edges from B. And C I have two edges, one from B and another from D. So it should be 0. And D also I don't have any kind of. So this matrix is going to be changed in case of directed graph and undirected graph. And what about this adjacency list? So in this one we're going to represent in the form of a nodes link list. So I have H, no H, so that's why it should be null. And B, I have H, so that's why I have to write it as A. And for C, I have H from B, and similarly I have H from B also. And for D, it should, I don't have any other edges, it should be null. So this, like this, we're going to present an adjacency matrix here. So let us consider. So adjacency matrix is a two-dimensional matrix, 2D matrix of size n by n. With 0 and 1, where ai is equal to 1 means that it should be there is an edge from I to j. So this is the graph we are having. So in this graph, uh, I have an edge from A to B, so it should be 1, and similarly A to C, and from B, so what are the edges? I have edge from B to A and B to D, and from C, I have an edge from C to A and C to D, and I have edge from D to B and D to C. So this adjacency matrix is a two-dimensional matrix uh, which is going to have zeros and ones. Whenever the value become 1 means that there is an edge from vertex I to vertex J. How this one should be in case of adjacency list here? So the adjacency list is a graph or diagram, should be a collection of linked list. So then all edges are going to be connected by my edge. So whenever there is an edge like this, so for A, so the edges will be B and then C. And for B, I'm going to have the edges A and then D. And for C, I'm going to have C and then D. So this should be the adjacency list representation of the graph. What are other types of graphs we are going to have? So the weighted graph is the graph so which assign number of value. So these numbers what we called as weights or costs. So example weighted adjacency matrix. So the weighted graph is the graph so with assigned number of to its edges, and these weights what we called as weights or costs here. For example weighted adjacency matrix. So in this case, I'm going to map those weights here in this matrix. So the edge, what is the value that is carrying from A to B? So that is 1. So I'm going to mark it as 1. And I'm going to take A to C. The edge is going to carry 2. So I'm going to take 2. And A to D as well. Similarly, if I'm going to consider D, so I have an edge from D to A, that should be 5. And D to B, that should be 4. And D to C, it should be 3. So like this, I'm going to map the weights of the edge in the adjacency matrix. So the matrix, what we can able to call it as a weighted. Similarly, here in weighted adjacency list, so along with the node values, I'm going to consider the weight value as well. So whenever the edge is going to consider here, so along with this, the weights are going to be carried. So for A, so I have the node that is connected is B, value is 1, and from A to C, uh, the value is 5, and A to D, the value is 2. So in weighted adjacency matrix, it is going to be include the vertex name as well as the weight also. Then comes to graph terminology. So we're going to discuss what is a node here. So the node is nothing but a collection of points. Call it as vertex or node, or what we can able to call it as point. An edge is nothing but a line segment between the two vertices. So the line which is going to be joined by the two vertices is called as an edge. So otherwise this should be normally a line segment here. An adjacency node, which means that so which is going to connect the near vertices. So A and C are adjacent, B and A are also adjacent. The next one is degree of nodes. So here the degree of nodes means that so the number of edges connected to that node is called as the degree of the node. So in this case, what is the degree 2? So in this case 1, it should be 1. So if I'm going to draw another one, A, B, C, and D. So what is this degree here? It should be 1. And degree is 2 here since there are 2 edges. And this is also 2 and this should be 1. So like this the degree is going to be calculated. So the number of edges that are connected to the node considered as a degree, and degree of A equal to 2 nodes and degree of B equal to 2 nodes. And next one is what is the size of the graph. So the total number of edges in a graph is considered as the size of the graph, and it should be 2 here also. So next one, path. Path is nothing but a sequence of vertices starting from initial node to the ending node. So the total number of edges in the graph is nothing but the size of the graph actually. So the number of edges in the graph is 2. So that's why the size of the graph is 2 here. And what is the path? So path is nothing but a sequence of vertices from starting node to ending node. So from that one I'm going to say that is. So if it is the source and this should be the destination, so what is the path here? So A to B, B to C, C to D. So otherwise another path is A to D direct. So this should be the source and this should be the destination. And next we'll see about the path length. So what is the path length here? The total weight of the distant value obtained by a particular path start node to the end node. Okay, so the total weight of the distance value that is going to be obtained from starting node to the ending node. So, in this one, what is the path length from A to B? So for this, I'm going to have A to B is one option, and I can able to go from A to C, C to D, and C to B. So if I'm going to have like this also, I can able to go from A to C, C to D. Another one I can able to go from A to D, D to B. And how the weights are going to calculate it. So the length of this AB is 1, and AC is 3 plus 4 plus 2, that should be 9, and here it should be 12, it should be 10. So 12 plus 2, 14, and A to D it should be 12 to 14. So like this we are going to find out the length of the path from starting node to ending node. And next one is connected graph. So what is a connected graph? So the every vertices are going to be connected. So whenever there is an edge from one vertex to the another vertex. So this is the connected graph. So each and every vertex is connected. A not connected graph. So not connected graph means, so here these edges are missing. So otherwise it should be fully connected. A not connected means some of the edges are not connected in between them. So that's why it should be a not connected graph. So every vertex are not connected. And next one we're going to see about a cycle. So cycle is nothing but a path from source to end at same vertex that does not traverse the same edge more than once. So cycle is the path of the source to the end at the same vertex and does not traverse from same edge more than once. So a cyclic graph means that a graph does not have the cycle, then it should be called as a cyclic graph. So here all the edges are connected and there exists a cycle here. So A to C, C to B, and C to A. So that's why it should be a cyclic graph. So whenever the edges are connected like this, it is also a cyclic graph. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.